Alright, hello everyone, I'm Mason McAnally and I'm going to be talking about some surface free energy, and I'm going to make the comparison between high and low density polyethylene. And so to do that I'm going to be using the Zisman Plot, and effectively what I'm calculating is the critical surface tension for the complete wetting of the solid surface. And to do that we graph cosine of theta against the surface tension. This is purely empirical. It kind of ignores some theory, and I'll later get into that. So why do we care about critical surface tension? Basically, the idea is that we can determine the exact point in which complete wetting actually occurs on that solid surface. And it's also an easy way to compare the surface free energy between a multitude of different surfaces, because we have multiple different types of plastic. We can make a quick comparison using this just with a few liquids. And so what you'll need is a dropper and syringe, high density polyethylene, in this case I'm using a plastic cutting board, low density polyethylene, Ziploc bags, and a range of different liquids. And hopefully those liquids encapsulate a wide range of contact angles, and that's going to give us more accurate results. And lastly, you're going to need a balance, and that's to find surface tension. And to find the actual surface tension, I'm going to be using the drop method. Basically, it's a force balance equation between the gravitational force and the surface tension force of the liquid. So effectively, these two are equal right before it drops, and then I use the balance to measure that mass. Okay, so this is everything that I'm using. Kind of one of the most important parts to this is determining the surface tension. And to do that, I'm basically just going to take this syringe and I'm going to very slowly drop into the balance. And basically the idea is that, after a certain amount of these drops, I'm going to get the mass from it, and then I have the radius from the tip, and I can use that to determine the surface tension of my different liquids. And since my balance minimum isn't the greatest, I'm doing it 3 times for every single liquid in hopes that I eliminate some of the error and the fact that the balance isn't the most accurate. Okay, so you can see that I did a hell of a lot of drops, and I kind of varied the amount of drops too, and we can see that I get pretty close for water in terms of what we see in the surface tension in libraries, which is about 72 millinewtons per meter. You can see here I get 76. And we can see that Mr. Clean is our lowest surface tension, so we're probably going to expect the highest wettability for Mr. Clean. So the next step that we're actually going to do is we're going to be looking at contact angles. Okay, so for the second step, we're going to be comparing, using the Zisman plot, the critical surface tension. And to do that, what I need to do is make contact angle measurements. And the idea is I'm going to be taking the syringe, I'm going to be doing a sessile drop onto each surface, the cutting board being the high density polyethylene, and then the Ziploc bag being low density polyethylene. And so hopefully I can see a difference between the two critical surface tensions. And so to start it off, all I'm going to be doing is going to be dropping a single drop onto the surface of the cutting board and a single drop onto the surface of the Ziploc bag. And then I'm going to be making contact angle measurements and plotting them and seeing if there is a difference between high density and low density polyethylene in terms of wettability. So here we can see a couple of the contact angles that I measured. You can see how the water on the low density polyethylene has a much higher contact angle than the vegetable oil. So here we have the Zisman plot for both of these. You can see that The orange dot is Mr. Clean. The reason that it's there is because I wasn't able to get a contact angle measurement. For the low density polyethylene, we can see that it probably does actually have a contact angle, but I was unable to actually take a picture and look at it. So we can see that the calculated critical surface tension for the wettability of the surface for low density polyethylene is 33.5 millinewtons, and HDPE is close by at about 29.8. I also looked at the literature value. The literature value for polyethylene is 31.6, and we can see that these two values actually bridge that. In conclusion, we can see that the low density version is a lower energy surface and therefore has a lower wettability. The error in this experiment, the drop method, there's obviously issues with the balance where multiple drops can under or overestimate the actual mass because the balance limitation is plus or minus 0.5 grams. And then lastly, the Zisman plot is something that's empirical. It's not really based in theory, and so we have effectively something that's ignoring interfacial tensions and polarity interactions between the solid and liquid surface.